Hi everyone, today I would like to discuss about precipitation, agglutination incubation reactions. We in earlier classes we already discussed about antigens, what are antigens, antibodies, their different properties, etc. And in this section we are discussing about the as a result of their interaction between each other there are some reactions occurs that are precipitations, agglutination, incubation reactions, etc. So let us look. First is precipitation reaction. Precipitation reaction. From the word, it's clear that as a result of their interaction, it gives an visible precipitate. So, in this reaction, it is between the interaction is between the soluble antigen and the antibody in an aqueous solution. That is very important. So, this interaction takes place in an aqueous solution and forms a lactose that gradually develops into a visible precipitate. And this reaction is named as a precipitation reaction. And in this reaction, the soluble antibodies or the antibodies that aggregate the soluble antigens which is present in the aqueous solution, they are called precipitins. So the antibodies that are present in the aqueous solution that can aggregate the soluble antigens, they are called precipitants. And this visible precipitate is a soluble antigen antibody complex, and this occurs within a minutes after the reaction takes place. And for the formation of the visible precipitate, it takes very slowly, and often it takes a day to 2 days to reach its completion. Hmm? And next is this precipitation reactions depends upon one property, that is it is based on the valencies, that is both the antigen and antibody must have a valency. So for the antibody, it must be bivalent. That means it must have more than one Fab site. This Fab site helps to bind with the antigen. In case of antibody, the Fab fragment is a site for the antigen binding. And so the antibody must be bivalent for the precipitation reaction to take place. If it is monovalent or monovalent Fab fragment, then the precipitate will not form. And in case of antigen, it must be bivalent or polyvalent, that it must have at least it must have two copies of same epitope, or it can be have a different epitopes. So this can help to react with the different antibodies that present in this polyclonal antisera. So with the help of this, different epitopes or to same copies of epitopes helps to binds with the antibody present in the aqueous solution. Then for this reaction, our next example is an experiment with a myoglobin. This experiment shows that or illustrate that why the protein antigen must be in bivalent or polyvalent for the precipitation reaction to be taken place. This experiment shows that myoglobin precipitate well with the specific polyclonal antisera, but it fails to precipitate with a specific monoclonal antibody. This is because here the antigen or the it contains multiple but distinct epitope multiple distinct epitope, but only a single copy of each epitope is present. That's why in case of monoclonal antibody, it fails to precipitate because only a specific monoclonal antibody is present, or it is with a single valency. So, but whereas in the case of a specific polyclonal antisera, it will be have bivalent. So as a result, it can forms precipitate. So the myoglobin does can form as a result. So this myoglobin can form a cross-linked lattice structure with a polyclonal antisera. But whereas in the case of monoclonal antisera or antibody, it can't form such a cross-linked lattice structure. So as a result of this formation of this cross-linked lattice structure, the precipitate is formed. So this forms the basic principle for many commonly used immunological assays. For this form or this stands for the or this precipitation reaction stands for the basic principle. Now we are coming to precipitin curve. What is a precipitin curve? So we already said it before that precipitation reactions are take or this precipitation reaction is taking place in an aqueous solution, that is a soluble antigen and a soluble antibody interact with each other in an aqueous solution. So here the precipitation reaction is taking place in a fluid, yields an precipitin curve. As a result of this reaction, it gives an precipitin curve. Then this curve is an or this reaction is an quantitative reaction or quantitative precipitation reaction. As a result, we can get how much amount of antibody or antigen present in a given sample. That's why this is called as a quantitative precipitation reaction. And this can perform or this precipitation for obtaining this precipitin curve, we can perform an experiment by placing or by taking we are taking the antibody as a constant, or we take an antibody in a constant amount and in a series of tubes so here the antibody is in constant amount and we are adding the antigen in an increasing concentration. So each tube and the amount of antigen we are adding is in a increasing form. The first tube has a little amount of antigen, then the second tube have again we increase the concentration of antigen in the second tube. Likewise we are adding the test tubes, series of test tubes. So as a result, as a result of their interaction, once the reaction interaction takes place, there occurs a precipitate or precipitate forms. So after the formation of this precipitate, we can take this tube and centrifuge into pellets, and thus it gives the amount of precipitate present takes place in the reaction, or amount of precipitate forms in the reaction. Thus we can calculate the amount of precipitate takes place in the reaction. So for this we centrifuge each of the tube and the amount of precipitate is measured in the each of the tube. Now we got the amount of precipitate forms in each of the tube. Now we are plotting this uh, amount of precipitate against the increasing antigen. Here we are taking antigen in the x-axis, and if we are drawing a graph with respect to this values, that is according to the amount of precipitate and increasing antibody concentration, we will get a plot, or we will get a curve. This curve is called as precipitin curve. So precipitin curve is formed by we are plotting or we are plotting the amount of precipitate against the increasing concentration of what antigens. So if you are drawing an x-axis, if you are drawing an x-axis and y-axis, along the x-axis we will take the increasing concentration of antigen, and in here we take in this direction, this is x-axis, and from here to here the antigen concentration is in increasing, and on y-axis we will take antigen antibody complex formed, or the precipitate, amount of precipitate formed on the y-axis, and we are marking respect to each of the tube where precipitate is formed. According to the precipitate formed, we are marked in on respect to the order. We'll get an curve called an curve. This curve is called as precipitin curve. So this curve has some significance that this plot gives amount of antibody precipitate versus increasing antigen concentration. So here we take a antibody is constant but the antigen is increasing amount. And another significance of this curve is that we can divide this precipitant curve into three zones, which are a zone of axis antibody, a zone of axis antibody, then equivalent zone or zone of equivalence, and the next is zone of antigen existence. So each of the zone have specific characteristics according to them. So in first zone is zone of antibody exists. So in here in this picture, the A represent the first zone, that is antibody axis zone. So in this case, on the first case, there will be axis and the antibody, and we are just adding the antigens little by little. So the antigens may not be seen easily, whereas antibodies are axis. That is very clear from this picture. The next zone is zone of equivalence or equivalence zone. This is represented by letter B, equivalence zone. Here the amount of antigen and the antibody is equal, and all are joined or a close linked structure. And next zone is zone of antigen existence. Antigen excessive means here the antigen is present in very high amount, whereas antibody is less compared to the before zones. So here excess and antigens can be seen, whereas antibodies cannot be seen. So these are the three zones present in it, or we can divide this precipitation curve. As a result, we will get three zones. And so these are the three zones. In the first zone, we already discussed that is zone of axis antibody. So as a result, the precipitate is less or inhibited because only a very few amount of antigen is present, and and the antibody that is not bounded to the antigen cannot be detected in a supernatant. So we can't easily detect this antigen antibody complex. That's why the precipitation is less or it is incubated in the first zone, and here the antibodies in excessive condition. The next zone is equivalence zone that I already described before, that in this zone the amount of antigen and antibody will be in equal, and this zone is also called as optimal. So this zone is a zone of maximal precipitation. So at this zone, the precipitation will be at maximum, and here the antigen and antibody concentration is optimal. So the concentration of antigen and antibody will be optimal, and all the antigen and antibody are in a bounded to each other. So no free antigens or free antibodies can't be seen in this zone, and antibody and antigen forms a large insoluble complex. As a result, there will be precipitate forms. And we already said that neither antibody nor antigen can be detected in supernatant. Uh, the next zone is zone of axis antigen. This zone, there will be antigen will be in axis condition. So here also the precipitation is inhibited, and we can't see antibody because antigen is in excessive condition, and antigen which is not bounded to or which are not bounded to antibody can be detected. That means free antigens can be detected in the supernet.